Namaste. Welcome back to the session of Basic Thermodynamics. In the previous session, we have gone through the measurement of dryness fraction, and we have seen different types of calorimeters by which we have measured the dryness fraction of the given wet steam. In clear, we have gone through throttling calorimeter and separating and throttling calorimeter. These two are the devices by which we have seen how to measure the dryness fraction of the given wet steam, and with the help of that we have ended up with the theory part what we have in this syllabus. So, now I will look on to the problematic part. Before looking on to any problem, let us try to understand how the formulation will be done while solving the problems. If we understand that at this stage itself, then it will be very easier for us to think on how to solve the problem, so that we can look on to the formulation with which we can go through the problems. We knew in this pure substance we will be dealing with two of the phases or mixture of two of the phases of the substance. Those are nothing but liquid, vapor. These two are the two phases, or liquid plus vapor, a mixture region, a wet steam. This is what is the mixture of two phases, either liquid or liquid plus vapor or vapor. In most of the situation, we are not going to deal with pure liquid. In almost all the situations, we will be looking on to either liquid plus vapor region, or we will be looking on to vapor region. So, now before moving on to the various formulation, let us recall what we have understood from various phase diagrams such as PV, TS as well as HS. I have taken two of the curves which those are nothing but saturated liquid line and saturated vapor line. We are very aware, on the saturated liquid line the liquid is saturated, on the saturated vapor line the vapor is saturated. If I want the dryness fraction X on the saturated vapor line, it is 1. If I want the dryness fraction X on the saturated liquid line, which is nothing but 0. What is the meaning of this? X is equal to 0 in the sense, on this line the dryness, I mean the vapor content in the substance is 0. On this line X is equal to 1 in the sense, on this line the entire substance has converted into vapor. So, that is what is a saturated vapor line to us. Anything which exists in between this is a mixture, which is nothing but liquid plus vapor region. Left to this line it is liquid, right to this line it is vapor. So, as I said, I will be looking on to liquid plus vapor region, or I will be looking on to vapor region. My intention will be focused either on this region or on this region to look on to various properties of the given substance. So, now if I look on to the notations, if the substance exists on this line, saturated liquid line, all the properties related to that substance will be expressed as a F, suffix F. If substance stands on this line, then all the properties related to that substance will be expressed as suffix G. Here F in the sense fluid, G in the sense gas. If I am making use of the suffix S, then I am talking with respect to the fluid's property. If I am making use of the suffix G, then I am talking with respect to the gas properties. That is what is the meaning of that. Then if anything exists in between, we do not have a particular point over there. It may exist on this point, it may exist on this point, here, 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 here. For that purpose, we have not given a specific notation for the situation in which the substance is existing inside the dome. So, what we have done is from here to here, this is F, this is G, from here to here in the sense from fluid to gas. This from here to here, in order to take the substance from this state to this state. What is this state? This is the saturated liquid state. What is this state? This is the saturated vapor state. From saturated fluid state to saturated gas state, whatever the amount which is getting confused, that which is getting utilized, that is represented by suffix Fg. Fg in the sense from fluid to gas, complete conversion of fluid, saturated fluid to saturated gas. So, this is what is the notation we use from F to G. then what we have to use at the in between sessions. So, that is very important thing. So, now let us try to understand that. I have written a tabular column wherein first column states with respect to saturated fluid, second column mixture, and the third column saturated vapor. So, now saturated fluid, in the sense this is the saturated liquid line. Whatever I write on this line, that will be expressed with the suffix F. Please look onto the properties now. Small h, which is nothing but the specific enthalpy of fluid, specific entropy of fluid, specific volume of fluid. That means F stands for saturated fluid and corresponding properties are denoted with the help of F. And look onto this saturated vapor. Saturated vapor is this, saturated vapor line is this, and whatever we are writing as the property on this line, that will be denoted with the help of G, specific enthalpy of the saturated vapor, specific entropy of saturated vapor, specific volume of saturated vapor. So, these are the notations. So, now make sure all the things are small letter, because of that I am calling it as specific. Specific in the sense all those properties are expressed with respect to unit mass, wherein mass of the substance is unity 1 kg. Now, come to this region, mixture region. I have two ways of writing or extracting the value of a specific property on that particular region. What are those? Let us try to look onto this. So, now if I want H somewhere in between F and G on a particular pressure, then H at that point will be equal to, I will start from this side, from fluid to gas. I need to initially add this F, that means H F. I am moving forward because of that, plus now it is a mixture, both fluid and gas are present over here. Now, you are moving in this direction. If you move in this direction, there is a meaning for the x, there exists a x times of, from here to here, what is that? From here to here, it is complete Fg. From here to anywhere in between, that is Hfg, which has been multiplied by x, which is nothing but dryness fraction. If I am moving completely from F to G, it is, what is the value of F to G? If I move from F to G completely, what is the value of x? This becomes 1. Then there is no meaning for this. It will be Hf plus Hfg. Hf plus Hfg, it will be equal to Hg. So, since x value is 1, Hf plus Hfg becomes Hg. Now, I am in between. So, I am moving from Hf and I am moving somewhere in the between. So, x times of from here to here Hfg in the forward direction. You can also come back in the reverse direction. I can start the interpretation from this point. So, H is equal to, I will start from Hg. Hg, I am coming in a reverse order. I have already moved forward, I am already in the forwarded point. So, now I have to come in a reverse direction. So, minus x. Now, I am not moving towards the dryness, already it has been completely dry, value of x is 1. Now, I am moving in a backward direction, in the sense I am moving towards wetness region. So, it is 1 minus x times of Hfg. That means complete dry vapor minus, you are going in a backward direction. If you are going in a backward direction, in the sense you are looking for wetness, wetness is nothing but 1 minus x times of Hfg. So, by doing this or by doing this, you will get the same value for corresponding property. The same analysis can be used for other properties also. If I want specific entropy, it is Sf plus x times of Sfg. If I want specific volume, Vf plus x times of Vfg, or I can make use of this also. In my practice, in my way of solving the problems, I will stick on to one such formula, which is nothing but this. For confirmation, you can make use of this also, but for all the cases, I will make use of this only. If I want any property in between the saturated lines, those are nothing but saturated liquid and saturated vapor line, then the formulation is H plus x times of HFG or S plus x times of SFG or V plus x times of VFG. So, now it is very clear. On this line all the properties are denoted with the help of suffix F. On this line all the properties are denoted with the suffix of G. If in between, then it has to be expressed as F plus x times of Fg. I hope these things are clear at this stage. So, now I will be looking on to the problem. So, before looking on to the problem, one thing should be very clear to us. The thing is, we need various properties for a particular pressure of the pure substance. So, now say for example, if this line is 1 bar line, if I am talking with respect to 1 bar pressure line, then what are the requirements for us? What are the various properties that I can define? F, HF, SF, VF, G, HG, SG, VG. In between, I can write many values for that particular state by including X, dryness fraction. Say for example, I will look with respect to the dryness fraction of 0.9. On the 0.9 line, what is the various properties, right? In such a way, we need various properties. This is for 1 bar pressure line. In the same way, 2 bar, 3 bar, 4 bar, 5 bar till the critical pressure. Where is that critical pressure? Here it is, Cp. So, till that we need to look for all these properties. We cannot remember all these properties on all the time. So, because of that, what they have made is they have given us the data handbook. While solving the problems, we need to make use of the data handbook. So, now I will be making use of the data handbook to look onto the various properties that are essential to solve the problem. So, make sure while solving the problems, we will be making use of data handbook, basic thermodynamics data handbook. So, by keeping this in mind, I will start with the first problem. The first problem says, find the specific volume. What is the specific volume denotation? Which is nothing but V, small v. Enthalpy, enthalpy here in the sense specific enthalpy only. Specific enthalpy denotation is H. Internal energy, what is the internal energy of the given substance? Of wet steam. He is clearly mentioning the steam as wet steam. So, we are dealing with wet steam over here. Make sure we are dealing with wet steam. At 18 bar pressure, he is mentioning us the pressure of the substance. Pressure small p, which is equal to 18 bar, and it has a dryness fraction of 0.85. What is the notation for dryness fraction? Which is nothing but X, which is equal to 0.85. What do you mean by 0.85 here? 0.85 in the sense 85% of the wet steam is dry. That means he is calling it as a wet steam. That means how much wetness is present? Already 85% is dry in the sense remaining 15% is wet. So, what is the wetness fraction? Which is nothing but 0.15 or 15%. What is the dryness fraction? Which is nothing but 85%. Pressure is given and dryness fraction is given. So, now we need to look for various properties, specific volume, specific enthalpy as well as internal energy. Before looking on to the solution, one thing you need to make sure that what is the state of the steam they have mentioned. Whether he is mentioning the superheated steam, whether he is mentioning the saturated steam, or whether he is mentioning the wet steam. All these three possibilities should be looked on to before solving the problem. So, now he has clearly mentioned the kind of steam is wet steam, in the sense steam consists of moisture. If he hasn't mentioned the statement as a wet steam, then initially your job is to find the kind of steam, what kind of steam it is. That has to be found with the help of X. If they have not mentioned the value of X, then You need to find the value of x first. Based on that, you need to decide the kind of steam. Let me tell you, you have the dome. Value of x on this line is 0, value of x on this line is 1. So now you have found the value of x. If they have not mentioned the x, you have to find it first. If you have found the value of x, let me say, if x is equal to 0, then what is the kind of substance you are dealing with, which is saturated liquid. If x is equal to 1, which is nothing but saturated vapor. If x lies in between 0 and 1, you are dealing with wet steam. If x is greater than 1, you are dealing with superheated steam. So this is what is the way of identifying the kind of steam. X is 0, saturated liquid. X is 1, saturated vapor. X is lying in between 0 and 1, it is nothing but a wet steam. If x is greater than 1, then it is a superheated steam. Please make sure what kind of steam you are dealing with. After getting confirmation of the kind of steam, you need to proceed with the problem. So now x is 85% and he has mentioned the wet steam. If x is taking the value in between 0 and 1, then obviously it is wet steam. So even though if we hadn't mentioned this data, it is understood that it has a dryness fraction, because of that it is wet steam. Now I am dealing with wet steam. Now the question is, for the mixture or for the wet steam, I need to look for the formulation. This is wet steam. The formulation goes like this: F plus x times of Fg, whatever the property you are looking for, F plus x times of Fg. So now look for the unknowns: specific volume, enthalpy, internal energy of the steam. So now I will look for V. V is nothing but specific volume. Specific volume of the given wet steam is Vf plus x times of Vfg. Now I am not aware of Vf and Vfg, but I am aware of x. From where I will get these two values? I need to look for the data handbook. Lot of values are available in the data handbook for various pressures. For the given pressure, I have noted down the properties that are required to solve the problem. What is the given pressure? 18 bar. At 18 bar pressure, I have noted down these properties from the data handbook. So let me look on to the value of Vf. Vf is this much meter cube per kg. I will substitute the value of Vf plus x. He has mentioned the value of x as 0.85 plus Vfg. Vfg is this much. I have not noted down over here, but Vfg value will be this much. Vfg and Vf I have taken from the data handbook. Upon simplification, the specific volume of the given wet steam, which is at 18 bar and which is having the 0.85 dryness fraction, is 0.09378 meter cube per kg. So this is the first unknown, which is nothing but specific volume. Next, specific enthalpy. Since it is a wet steam, the formulation remains same. H is equal to Hf plus x times of Hfg. Hf and Hfg needs to be extracted from the data handbook. I have written the Hf and Hfg values. Please substitute Hf and Hfg along with the dryness fraction. You will get the H, specific enthalpy value for a steam which is at 18 bar and having the dryness fraction of 0.85. Next thing is internal energy. Here we have not spoken with respect to internal energy. Let me speak with respect to internal energy now. Internal energy is nothing but the energy that is present in the given substance at any situation. What is the amount of energy the substance possesses at any given situation or at any given point is nothing but the internal energy. Now by making use of that definition, I will be looking on to internal energy. So now H is equal to U plus PV. This is the basic definition of enthalpy. H is enthalpy, which is nothing but summation of internal energy plus flow work. Internal energy is represented by U, flow work is represented by P into V, product of pressure and volume. Make sure all the things are specific in nature. Now I need to get the value of U. Please solve this equation for U. U is equal to H minus PV. Make sure you have got H in terms of kilojoules per kg, Pressure should also be substituted in terms of kilo. Here pressure has been given as 18 bar. let me give you the hint. 18 bar is nothing but 18 into 10 to the power of 5 Newton per meter square. Since I am substituting the value of H in terms of kilo, pressure should also be substituted in terms of kilo. So 18 into 10 to the power of 2 into 10 to the power of 3 Newton per meter square. I can write this 10 to the power of 3 as a kilo Newton per meter square, so that this becomes 18 into 10 to the power of 2 kilo Newton per meter square. So I have written P value as 18 into 10 to the power of 2 into specific volume for a particular state has been already found. This is the specific volume. So now you can raise the question, why I have not used UF, HF minus PF, VF or PFG, VFG? No. Whatever the terms which are present inside the U, what are those terms? H, P and V. H I have already found for a particular point. Already it has been used as HF plus X times of HFG. P they have mentioned. V I have already found by using F plus X times of FG. So now it is not required again. Again I do not have to go for F plus X times of FG formulation. Already I have the values at that particular point, because of that direct substitution is required. So upon substituting, I will get the internal energy of the substance as 2339.451 kilojoules per kg. So now this is how you need to solve the problem. Make sure initial step while solving the problem is you need to look onto the kind of the steam, decide the kind of the steam and then look for the various properties that have been mentioned in the data handbook. Okay, let us move on to the next problem now. Let me read the problem for you. Find the dryness fraction. Dryness fraction is notated by X. X is question mark. Specific volume, small v is question mark. Internal energy of the steam, small u, which is question mark, at 7 bar. 7 bar is nothing but the pressure of the steam. So pressure is 7 bar, bar is splitted as 10 to the power of 5. So 7 into 10 to the power of 5 Newton per meter square. So 10 to the power of 5 Newton per meter square is nothing but the bar. That is what is the notation of pressure. Enthalpy of steam is given to us, which is nothing but 2550 kilojoules per kg. 2550 kilojoules per kg. That is nothing but the enthalpy of the steam. So now what we have to understand here is they have not mentioned the kind of steam we are dealing with. What is our first job? We need to find what kind of steam we are dealing with. Then we have to extract the properties either from the data handbook or from the charts which are available to us. So now enthalpy is known, pressure is known, but I do not know the value of dryness fraction. Here one thing is for sure, if X is equal to 0, I am dealing with liquid. If X is equal to 1, I am dealing with dry vapor, saturated vapor. If X is greater than 1, I am dealing with superheated vapor, wherein X does not matter. Now if X stands in between 0 and 1, then I am dealing with wet steam. First try to fix this. How to fix the value of X, or how to find the value of X so that I can decide I am dealing with this kind of steam. I will make use of the same formula, H is equal to HF plus X times of HFG. Now why I am making use of this, even though I am not aware of the kind of steam? One thing I am very aware that if X comes out to be 0, it is liquid. If X comes out to be 1, it is dry vapor. If X comes out to be greater than 1, it is superheated vapor. For that purpose, I have made use of this formula. Why only H? Why not specific volume? Because H is given to me. I need to make use of the given data. So H at pressure 7 bar is given. For that purpose, H has been extracted at 7 bar. I have extracted various properties at 7 bar from the data handbook. Now I will substitute the various values to this equation. Let me look on to the values. H they have given 2550, HF at 7 bar I have extracted, plus X I am not aware, HFG at 7 bar I have extracted from the data handbook. So now If I solve this equation, x turns out to be 0.8973 or which is equal to 89.73 percentage. So now I need to decide the kind of steam. What is the value of x now? 0.89 or 89%. What does that mean? I mean the steam is 89% dry, remaining 11%. It is 89.73, remaining 10 point something will be wetness. That percentage of wetness is present in the steam. That means I am dealing with the steam which consists of fluid, I mean liquid, as well as the gas. That means it is a mixture. I am dealing with wet steam. It is very confirmed now. We are dealing with wet steam. Because of that, x is having a value in between 0 and 1. Now it is very easy for us to go through the rest of the things. V, specific volume. I am dealing with wet steam. Because of the same form, because of that I am going through the same formulation. Vf plus x times of V of g. V is equal to Vf plus x. I am very aware of x now. V of g can also be written as Vg minus Vf. I have extracted Vg and Vf from the data handbook. If I substitute the values, it will turn out to be 0.2447 meter cube per kg. What is the meaning of this? Specific volume is this much, 0.2447 meter cube per kg, in the sense the volume occupied by the mixture, what he has mentioned to us, per kg is that much. 1 kg of mixture is going to occupy this much amount of meter cube. That is what is the meaning of specific volume. Next, last unknown is internal energy. We have to find the internal energy by making use of enthalpy formula. H is equal to U plus PV. Here internal energy is U. Solve the equation for U. U is equal to H minus PV. So U becomes H minus P times of V. So that U becomes this much. Here make sure H is in terms of kilo. Because of that, pressure is also in terms of kilo. I have solved the pressure. Here 7 into 10 to the power of 5 Newton or 7 into 10 to the power of 2 kilo Newton per meter square. Because of that, I have substituted 7 into 10 to the power of 2. Upon solving this, you have got the internal energy as 2378.72 kilojoules per kg. So now dryness fraction, specific volume and internal energy all are aware to us. We have found all the values of properties of the given wet steam. So that is what is the problem to you. So now let us look on to the next one, a different kind of problem. Let me read it. A rigid vessel contains 1.5 kg wet steam. He is clearly mentioning, he is talking with respect to wet steam. Wet steam in the sense we are dealing with both liquid and vapor. It is a mixture. So first data is wet steam. Its mass, wet steam's mass is 1.5 kg at certain pressure. He is not mentioning the pressure now. At certain pressure, a container is containing wet steam of 1.5 kg. So now mass of the wet steam is 1.5 kg. Since it is a wet steam, it consists of both fluid and gas. Mf plus mg is 1.5 kg. By adding both fluid and gas, I am getting 1.5 kgs. Now let me look on to the problem. If 8% of this mass, what is that mass? 1.5 kg. In that 1.5 kg, 8% is liquid. 8% of the given steam is liquid. Find the dryness fraction of the mixture. What is the dryness fraction? That needs to be found. Dryness fraction is given by X. It is very clear, it will have the dryness fraction. Why? You are already aware of the kind of steam that you are dealing with. What is the kind of steam? It is nothing but wet steam. Because of that, it has to possess wetness fraction, or in other words, it is dryness fraction. So now the problem is clear. A container consisting of the wet mixture whose mass is given to us, and among that certain percentage of the steam is liquid. That is the one more data, and we need to find what is the dryness fraction. The formulation looks to be very simple. Let me look on to the formulation now. Mass of the wet steam is known, which is nothing but 1.5 kg. Now mass of the liquid is given to us in terms of percentage. Mass of the liquid is given to us in terms of percentage. So, I will write that over here. Mass of the fluid is 8% of total mass of the substance. Mass of the fluid 8% of total mass of the substance. Now, we are aware of mass 1.5 kg, 8%, 8 divided by 100, 0.08 times of 1.5, so that you will easily get the value of mass of the fluid. Among 1.5 kg wet steam, this much of fluid is present, this much kg of fluid is present. So, mass of the liquid is very clear to now. So, if I make use of the overall mass formula, overall mass I have already written mf plus mg. So, m is equal to mf plus mg. You are aware of overall mass, you are aware of mass of the liquid now, mass of the fluid, and you can easily find the mass of the gas upon substitution. 1.5 minus 0.12, we will get the mass of the gas as 1.38 kgs. That means, out of 1.5 kg of the steam, 1.38 kg is gas and remaining 0.12 kg is fluid. So, we have got individual masses. Mass of the gas is known to us, mass of the fluid is also known to us. If I add those two things, I will get the mass of the wet steam. Now, the question is dryness fraction. Here, I am not provided with any of the properties like enthalpy, entropy, specific volume, etc., etc. But he wants me to calculate dryness fraction. In the previous problem, they were mentioning the one of the property of the steam, which is nothing but the H, enthalpy. Here, enthalpy, entropy, volume, nothing has been mentioned to us. We need to find the dryness fraction. In these situations, I need to go back to the original definition of dryness fraction. What is the definition of dryness fraction? It is the ratio of mass of the vapor present in the given mixture to the overall mass of the mixture. Mass of the vapor to the overall mass of the mixture. Vapor is denoted by mg, mixture is denoted by mg plus mf, as simple as that. We are aware of the mass 1.38 divided by 1.38 plus 0.12, that turns out to be 90.92 or 92%. That means, the steam what they have mentioned to us is 92% dry. If the question is what is the wetness fraction of the given steam, you can easily answer 92% is dry, in the sense remaining 8% is wetness. So, that is how the problem needs to be solved. A different kind of problem, a simple one, we should be aware of the basic definition of dryness fraction. So, this is what is for the today's session. We will meet in the next session with few more problems. Till then, namaste.